So in the last video, we came to this conclusion from the question we're solving. We realized that we had a sequence, and the sequence can be finalized as 1 over n, right? Now, we have to prove the Bolzano-Wierestrass theorem, which basically means, is this sequence bounded, right? Is there a number which this sequence will never approach, right? So that's what we are trying to find. Now, we are saying yes, there is a number it will never approach, right? How? So we say that this sequence first is greater than 0, right? And now there is an element called delta, right? Which this sequence would never approach. Now we try to find the 0 neighborhood because we assume that every small element we choose will be greater than 0. So we first find the 0 neighborhood, and that's what it is. So 1 over n minus 0. Right. Now we solve the equation. Realize that the left hand side of the equation is not any interesting, right? I mean, 0 is less than or equal to 1 over n. When you try solving, you get infinity and anything, but it's not really interesting. So let's take the right hand side. The right hand side says that 1 over n will be less than or equal to what? The delta, right? Now I know usually we see the delta is a very small number, not equal to the limit. But here we are assuming that we can give the delta a very large number, even approaching the limit, right? So that still it will still be in the neighborhood of the sequence, right? So you realize that when you solve this, you realize that you get n is greater than 1 over delta. Now what does it mean? It means that so far as n continually progresses, given that n is greater than 1, so far as n continually progresses, you always find an integer where that integer is greater than 1 over the limit point, right? So, for example, it means that the sequence will continually um, keep on decreasing, like it will start converging, right? So you realize that the greater the value of n, the smaller the value of 1 over delta, right? So for example, if n was 10, you realize that I get 1 over delta of 0.1, like 1 over delta will be less than 0.1. Now if n is 100, 1 over delta will be less than 0.01, right? So you realize that as your n is increasing, the 1 over delta continually decreases, and that's what you are basically showing, that the sequence tries to converge at a particular point. And once a sequence starts converging, then we know that definitely it will converge. Then it means that it is bounded, right? So it's just to show the convergence of the sequence. Mostly these proofs are very basic, like the logic is, yes, that's what it means, but it sounds so, how should I put it? Reasonable, like, yes, I mean, if you have 1 over n and the n is continually increasing, it will converge. But I mean, that is what you are trying to prove, and it sounds so not very profound, but you realize that in advanced proofs. Now, they have another sequence, and the sequence is made up of the set 1 over 2 exponents n. And they are trying to see if it satisfies the Bolzano-Wierestrass theorem, right? So, they start from and they are using natural numbers, right? So, the sequence will start from 1 over 2, 1 over 4 to 1 over 8. Now, you realize that clearly this sequence is bounded. Why? The first element, I can find first, it has a first element. That's what you should notice. It has a first element, right? Since it has a first element, I can find a number which is what? Always greater than or always less than this first element. For example, if I choose 0, it is always greater than half. It's always less than half, sorry. If I choose minus 1, it's always less than half. And that's what you see, right? And also the last element, although I don't see the last element, and here's the logic, although I don't see the last element, I realize that the sequence continually is decreasing, right? For example, 1 over 4 will be greater than 1 over 8. 1 over 8 will be greater than 1 over 16, and continuing, right? So I realize that even though it's decreasing, I'll never also get to what? 1, right? So I realize that it is clearly bounded because I can find two numbers which can clearly, shall I say, uh, clearly contain all the, or a range which can clearly contain all the elements of the set, then it means that the set is bounded, right? And they said therefore it obeys the Bolzano-Wierestrass theorem. But to prove that 0 is a limit point, so this is a specific proof to show that 0 is a limit point, then it means that if you find the neighborhood, right, and you realize that the formula for the later neighborhood was this one, right, where this one is just your formula for the set, right? So for every n, 1 over 2n minus 0, the magnitude should be less than a delta, right? Now, when you try solving it, you realize that the 0 side is not interesting much, so it's the right hand side you start solving. And now, I mean, this is from previous maths, but let's go through it for the sake of being thorough. Now, you try multiplying both sides by 2 raised to the power n, right? So you realize that this 1 over 2 raised to the power n becomes less than what? Delta, right? Then this is the same as delta over 1, and you can cross multiply, right? So when you cross multiply, you get 1 is 1 over delta is less than 2 it's less than 2 raised to the power n, and that's what you see here, right? Now you can take logarithm of both sides because this is an exponent, and when you continue you get this. Now what you realize is that this is logarithm of a number divided by a log of 2, right? Remember, log of 2 is a constant, right? So yes, because log of 2 is always log of 2, but this number is going to be varying. So it's clear that there will always be an integer n of delta such that 1 over 2 raised to the power n is less than what? 0. So usually the whole point is when you're able to make n the subject of such a statement as this one, right? If the same quote is what you see, right? You actually see the same quote. Because the truth is once you find the sequences actually converging, right? There is nothing much to say about it. But this is just a thorough proof to show you that, right, in abstract terms. It doesn't make much sense, right? But we'll go through that. So I think with that we can treat our next topic, and I was very happy that we are mentioning convergence, right? So you can now know that something starts converging when you have an upper bound, right? And it's very necessary because it will take us through the introduction of our next topic, which is sequences. And we have the definition of a sequence. So if you have a set of numbers, u1, u2, u3, right? Now this set of numbers must have a definite order of arrangement, and it must be formed from a definite rule, right? Then every number in the sequence is called a term of the sequence. So u1 is a term, u2 is a term. That's what they are saying, right? Now, if the sequence has a last term, then it is called a finite sequence. If the sequence does not have a last term, it is called an infinite sequence. Now, this is basically from the same things we have been treated about. Then you realize that they just kind of repeat, right? So we have um, infinite sets, right? That is if you don't know the last element and you have a finite set, right? You can have an infinite set, which is what? Which is countable, or vice versa, right? But for now, let's focus on sequence. So for example, the sequence 1, 2, 3 up to 20 is a finite sequence, right? It's a finite sequence because there's an orderly arrangement, right? And there's a specific rule. If I know the previous element, I just add 1 to get the next element. And this sequence is an infinite sequence, right? It's an infinite sequence because I don't actually know the last element, but I just know the rule as what? 1 over n, right? 1 over the natural numbers. And it's as easy as that. However, there are types of sequences, and for the starters, we'll only take the first one, then we'll continue in the next video. So for the very first type of sequence, it's called an arithmetic sequence. And this sequence just uses an arithmetic relationship. Now, what you should know about this sequence is that there is a definition called D, called the constant difference, right? And that D is a constant. It means that no matter any two consecutive terms of the sequence, right? If you subtract them, you should get that the tens must be consecutive, and that's what you see the UN plus 1 and the UN for. The UN plus 1 means that the element ahead, and the UN means the element in the past, right, or the current element. If you subtract them, you should get what? D. Now, the sum of the first n term of a sequence, and I believe this was done quite in SS, is given as what? N over 2 multiplying 2a into brackets n minus 1d. Yes, this was done in SHS, but let's go through. So it means that the sum of the first sentence, so if you want the sum of the first 10 terms of a sequence, n will be 10 here, so it will be 10 over 2, multiplying 2a. A represent the first term of the sequence, right? Plus n minus 1 times d. D is the constant difference, and you already know that. So, for example, you have this sequence, and this sequence is called starts like 2, 5, 8. So you realize that it's arithmetic. Why? Because you try finding the constant a difference and realize it's a constant. 5 minus 2 is 3, 8 minus 5 is 3, 11 minus 8 is 3, right? And that's it. You have your D. Now you put it back into the formula, right? So this, you are trying to find the sum of the first n terms. So they are trying to find the sum of the first 10 terms. So the n here will be 10. So 10 over 2 multiplying 2 times a, right? Remember here 2 times a. So 2 times a, where a is 2, right? Plus n minus 1 times d, right? N is 10, so n minus 1 will be 9 times d. D is what? 3, right? And you put it into the formula and you get what? 155. Now that's for an arithmetic sequence. Very simple, and there isn't much of examination they can ask from it apart from questions like this. Probably I'll add more complicated questions to the end of the slides. Yes, so that's it for this one. Like, share, and subscribe. Thank you.